Okay, so today, okay, we'll continue our discussion on question 7. Okay, right now we are on problem 7. Okay, exercise 1. So, okay, we are looking on part A. Okay. Okay, so yeah. First step, you differentiate, find your derivative function. After that, evaluate the gradient at x equals to 1, okay, which is negative 1. Then find the gradient of normal, okay, which is negative 1 divided by dy dx. Okay, the value of a dy dx. In this case is minus 1. Okay, so the answer will be positive 1. Okay, the negative sign cancel. Okay, and then the last step, okay, divide the equation of normal using the point they give you. In this case is 1 and minus 1. Okay, you put so. Okay, so this part is the general definition. Okay, the next part, okay, you just sub in your value. Okay, our y1 here is minus 1, right? So this will become plus 1. Okay, and then your gradient of normal is 1. Okay, or don't put also can. Okay, because 1 times anything is the same thing. Okay, so x minus 1. Okay. Okay, then, okay, just do some simplification. Okay, make everything in the form y equals to mx plus c. So, okay, our left hand side will be y. Okay, right hand side will be x. Okay, then the positive one on the left side, I move over it. I subtract 1 on both sides. So minus 1 minus 1 minus 2. Okay, shown. Correct. This part they ask to show, right? Correct. This is part A. Right. Y equals to come to. Aiyo. What's wrong? Why cannot bow? Okay, a bit slow. Okay, so yeah. Okay, yeah, part A. Okay, so we done. Okay, we already proved the equation of normal is y equals to x minus 2. Can? Yeah. Okay, are you done part A? Okay, so just okay, I just repeat the steps again. Actually, 4 steps. Okay, step 1, find your gradient function or derivative function. Then step 2, evaluate your derivative function at x equals to 1. Step 3, find gradient of normal. Okay, if they ask you to find equation of tangent, then you don't need gradient of normal. Okay, in this case, okay, they ask you to derive the or prove the equation of normal is x minus 2 equals to y. Okay, then you find the gradient of normal. The step 4, okay, you derive the equation of normal. Okay, using this definition. Okay, actually this definition comes from your gradient formula. I think I illustrated this last week. Okay, it comes from your gradient formula. Okay. Okay, then part B. Okay, part B is interesting. They ask you to prove or show that the x coordinate of the point of intersection of the curve C and the normal N. Okay, normal means 90 degree in mathematics. Okay, satisfy the following cubic equation. Okay, then they ask you to solve this equation, hence find the coordinate of the point where the normal meets the curve again. Okay, so very simple. Okay, since we are asked to prove that the point of intersection of the curve and the end satisfy that cubic equation there, right? So all you need to do is, okay, from part A and the given question, you take the curve equation, you equate to your equation of normal. Okay, then you will get down to this cubic equation here, x cubed minus 2x squared minus x plus 2 equals 0. Okay, so if you take, okay, copy and paste. Okay, you take this cubic equation, x cubed minus 2x squared, you equate to your equation of normal, which is x minus 2. Okay, and then, okay, you move everything from the right to the left over, okay, so that the right hand side becomes 0. Okay, you have the following. Okay, we have x cubed minus 2x squared minus x plus 2 equals to 0. Okay, precisely that cubic equation in part B there. Okay, x cubed minus 2x squared minus x plus 2 equals to 0. Okay, then the next part is, okay, so actually we already show already. Okay, part 1 show that the x coordinate of the point of intersection of the curve C and N satisfy that cubic equation. Okay, we already show. Okay, since the keyword here is intersection point or point of intersection, right? So we take the curve equation, we equate to the equation of normal. Okay, the one they asked to show in part A. Okay, you equate together, okay, you get the following cubic equation. Okay, then the next step is you need to solve this cubic equation, right? So recall how you solve this cubic equation. You need the tools that you learn in E-math as well as A-math polynomial topic. Okay, so to solve cubic equation, there's a few various methods lah. Okay, one of the common method I'll use will be try and error lah. Okay, so by trial and error, Okay, so if you, okay, first I set this cubic equation to, let's say, f of x. Let f of x equals to this one. Okay, then by trial and error, okay, let's say you sub in 1. Okay, if you get 0, means what? If you sub in x equals to 1 into the cubic equation, means x minus 1 is a solution of the cubic equation. As simple as that. So now if you sub in 1, okay, you get 1 cube minus 2 times 1 square minus 1 plus 2, right? And what is this? 1 cube is 1. 1 minus 2, negative 1, right? Negative 1, subtract 1, negative 2. Negative 2 plus 2, kosong, 0. Right? So this tells you, okay, x minus 1 is a solution of f of x. Clear, Charlene? Okay?
Can I ask,
Yes.
can we do, because they say intersection, right? Can we do simultaneous equation?
Okay, technically, this step, okay, when you equate these two equations together, on the left you have a cubic equation, on the right you have a linear equation. Technically, what are you trying to do? You are trying to solve these two equations together, right? Yeah lah. Okay, so it's the same idea. Okay, and because they tell you point of intersection, okay, it's like I have a curve and a line that bisects the curve. So if I want to find the intersection point, usually the common approach you do what? You take the curve equation, you equate to the linear equation, right?
But after we equate, right, can we solve it simultaneously? Like, I mean...
Okay, after you equate already, then you will not get another equation. You get a single equation, correct? Which is in terms of degree 3. Okay, and this kind of equation, the only way to solve is using, okay, one of the common approach is trial and error. Okay? Okay, or you can use your cubic identity to factorize out x cubed minus 2x squared minus x plus 2 equals 0. Okay, so after you equate already, okay, you will no longer get a simultaneous equation, it's a single equation. Right? So the only approach is, okay, you can either use your cubic identity, okay, a cubed minus b cubed, okay, the identity, or try and error to find the roots of the equation. And because it's a cubic equation, so I should have 3 roots. Okay? Do you understand?
So can just key into calculator.
Can also lah. Okay, can also. Okay, but if you are required to show the steps, if let's say part B, let's say you have let's say certain marks, let's say 5 marks, then very likely working step has to be shown. Okay, to get the marks. Okay? Then you have to show steps. Okay, down here, okay, you are free to use calculator. Okay? So we only got one rule. So let's say now let's say we test the second value. Let's say you sub in 2. Okay, wait, let me do something. Okay, so yeah, so where are we? Okay, now we are finding the second rule. So now if you test 2, okay, so you sub 2 inside. Okay, here you get the following. Okay, so 2 cubed is 8, right? Correct? 8, then minus 2 square is 4. 4 times 2, 8. So essentially this part will be cancelled out. Okay, then minus 2 plus 2 also cancel out, right? So kosong plus kosong, kosong lah, 0. So if you get 0, means what? Means x minus 2 is a solution of the cubic equation. Okay, so let me just copy and paste this part. Okay. Okay, so for the second part, x minus 2 is the solution of f of x. Okay. Okay, then now, okay, and okay, now if you try 0, obviously if you try to plug 0, you will not get equals to 0, right? Correct or not? Okay, because 0 minus 0 is 0, plus 2 is 2, which is not 0. So x minus 0 or simply x cannot be the solution of f of x. Okay? So if you try to plug negative 1, Okay, let me just copy paste this part. Okay, let me just copy paste this part here. Okay, so if you try to plug negative 1, okay, into the cubic equation, okay, minus 1 cube. Okay, minus 2 times minus 1 square. Okay, minus 1 plus 2. Okay, then you evaluate. Okay, minus 1 cube is negative 1. Okay, then minus 1 square is 1. 1 times 2 is 2. So minus 1 minus 2 is minus 3. Okay? And then negative 1, right? 1 plus 2, 3. So minus 3 plus 3, 0. So this tells you that x plus 1 is a solution of f of x. Clear? This is how you solve cubic equation. Okay, so the last part is x plus 1. Understand? Okay, then okay, so we have actually three roots. Okay, because cubic equation you have 3 roots. Okay, if it's quadratic equation, then okay, either 1 root or 2 roots. Okay, so f of x equals to, okay, you copy paste this one. F of x equals to x cubed minus 2x squared minus x plus 2. Okay, it's also equivalent to x minus 1, x minus 2, x plus 1 equals to 0. Clear? Okay, and therefore this implies, okay, the following step implies that x is equals to 1, 2, or minus 1. Okay, 3 different roots. Clear or not? Okay, so once you have the respective x coordinate, okay, you just substitute into your equation curve, okay, to find the respective y coordinate. So for x equals to 1, okay, if you just plug into what's my curve equation? You plug into this one, y equals to x cubed minus 2x squared, your equation of curve. Okay, you get 1 minus 2 is what? Negative 1. Okay, y equals to minus 1. Okay, for x equals to 2, okay, you do the same thing. Okay, come so okay, for x equals to 2, okay, you do the same thing. Okay, 2 cube is 8, right? 8 minus 8 is 0. So x equals to 2, okay, your y coordinate will be 0. Okay, and the last one, when x is minus 1, okay, minus 1 cube is negative 1. So negative 1 minus 2, negative 3. Okay, okay, clear? And I think the question, they give you one of the point, right? Correct? They give you 1 comma minus 1, right? So this one is given. Okay, I write here. This is given. Okay, therefore, okay, they want you to find the coordinate of the point where the normal meets the curve again. Okay, so actually they already supply you one pair of the answer. Okay, in part A. Okay, so the other two coordinate will be this one 2, 0 and negative 1, negative 3 Understand? Okay, that's the answer. Okay, this 2 is the answer. Let me bold this up. Okay, this 2 is the answer. Clear? Okay, so regarding to your question just now, okay, like you solve simultaneous equation. Okay, so when you equate the equation of curve and the equation of normal together, okay, you no longer get another equation. In fact, you get one single equation, and that single equation is in terms of cube. Okay, the degree here is 3, power 3. Okay, which means, okay, you need to use, okay, the tools that you pick up in polynomial and partial fraction, that chapter. Okay, actually polynomial only lah. Okay, you need to use that tool there that you pick up in polynomial, okay, to solve cubic equation. Okay, one of the approach I use is trial and error lah. Of course, you can use factorization also. Okay, but trial and error is the most common one lah. Okay, you just plug in any number. Okay, usually the number need not be so big lah. Okay, it can be very small, like 0. It can range between -3 to 3. Okay, so and if you plug in arbitrary numbers like what I do here, 1, 2, and -1. If you get 0, means f of 1, f of 2, f of -1 is the solution, which means x minus 1, x minus 2, and x plus 1 is the solution of the cubic equation. Clear? If you don't get 0, then it's not a solution. Okay, recall there is something called factor theorem in polynomial. Okay, factor theorem means that, okay, when you take the divisor, you divide by the dividend. Okay, as long as you have remainder 0, this means that, okay, your function is a factor of the divisor. Okay, that is your factor theorem. Okay, so as long as you get 0, then you get a solution. Okay, if you don't get 0, means you need to try other number. Okay, that's why it's called trial and error method. Okay, there are many ways lah. There are many ways to solve cubic equation. Clear? Okay, before I move on to question 8, okay, I want to show you the graph. Okay, so you can see y equals to x cubed minus 2x squared is shown down here, right? And obviously, okay, it's shown down in red color. And then after that, you have also the equation of normal, correct? The one in part A. Yeah, this one, correct? Okay, y equals to x minus 2 is the equation of normal, right? So if I enable that, okay, you will see that, okay, the coordinate 1 and -1 will pass through the equation of normal. Okay, because normal is like 90 degrees, right? Show that the normal to the curve at the point 1 minus 1 has y equals to x minus 2 equation. Okay, so okay, when I enable this equation of normal, okay, you will see that 1 and -1, that point will pass through it. Okay, so I enable. Okay, and then you see this coordinate is down here. Okay, can you see this one? The one that is being shown here. Can you see or not? Okay, the blue color one. This is your 1 minus 1. Okay, and clearly, okay, this point pass through the equation of normal. Okay, as well as the curve. Okay, okay, now next will be the cubic equation. So which is x cubed minus 2x squared minus x plus 2. Okay, so obviously it's a cubic equation. So there should be 3 points that will pass through the curve equation. Okay, as well as your equation of normal. Okay, so you see now I enable the one in purple. Okay, I hope you can see. Okay, the one in purple. Okay, you see the first point is what? -1, -3, right? Which is what we get just now, okay, when we do by hand. Correct? X minus 1, y equals -3. Okay, the second point, okay, that pass through the curve and the equation of normal is what? 1, -1, which is given to you, correct, in the question. And the third point is 2, 0. Okay, which is what we work out by hand just now. Can you see? This 3 part, okay, is what we work out by hand, correct, using the trial and error approach. Okay, so clearly you see graphically you get the same thing. Okay, so what is my point trying to explain here to you? Okay, using graphical approach. Basically, I want to show you, okay, if I have a curve equation and the equation of normal, okay, basically there should be 3 points, okay, that will pass through your curve equation and the line that is perpendicular to the curve. Normal means perpendicular. Okay, okay, maybe I can show you. Now I have laptop. Okay, if you just go and Google search, okay, what does normal means in mathematics? Google will tell you perpendicular lah. Okay, so I just show you. Normal, or just normal in calculus lah. Okay, normal in calculus term. Okay, you will see that it's perpendicular. Okay, can you see? In calculus, okay, the normal refers to a line or vector that is perpendicular to a certain line. Okay, this line is a tangent line. Okay, so the keyword is actually this one. Okay, so normal in mathematics is just right angle lah, perpendicular. Okay, and you can see that if I take away this one, you can see that the blue one is the equation of normal, right? The red one is your curve equation, and you can see that there is some kind of right angle down here, correct? At this 3 point, 2, 0, 1, -1, and -1, -3. Okay, there is some sort of right angle there. Okay, so that's why it's called normal. Okay, normal to the curve. Okay. Okay, some keywords are very important to know lah. Okay, when we study calculus. Okay, like the word tangent, normal, derivative function, gradient, things like that. Okay, these are keywords that you should take note. Okay, whenever you work on calculus related problem. Can? Okay, not can you? Okay, I give you 10 minutes. You try question 8 first. Okay. Okay, let me pause the recording first. Okay, so for question 8, okay, you are given the following equation of the curve. Actually, you know from this equation, you know it's actually a hyperbola, which means two curves that is facing over each other and never look at each other. Okay, so I can show you the plot. Okay, you see the plot is here. Can you see? Okay, because 1 over x is actually like that. Correct? And then you have a 4 in the numerator, so the entire graph translates 4 units vertically upwards. Okay, so it's actually a parabola. Okay, so part A and part B are similar. Okay, just that one asks you to show the equation of tangent, the other one asks you to show the equation of normal. So like I say, the very first step, you find your gradient function. Okay, so okay, you differentiate, you should have negative 4 over x squared, or equivalently negative 4 times x to the power minus 2. Okay, then evaluate the gradient at x equals to 1. Okay, so just plug in x equals to 1, you have minus 4. Okay, and using the point 1 and 4, okay, your equation of tangent will be y equals to minus 4x plus 8. Okay, and this is equivalent to 4x plus 8y. Okay, if you make in the form of ax plus by equals to c. Okay, this is the gradient slope equation. Okay, okay, which is also in under coordinate geometry. Okay, then for part B, okay, before you find your equation of normal, you need to find your gradient of normal, which is minus 1. So from part A, we know that our gradient evaluated at x equals to 1 is minus 4, right? So the gradient of normal will be 1/4. Negative 1 divided by negative 4. That is 1/4, or 0.25. Okay, then okay, you just replace, instead of minus 4, okay, in part A, you replace by 1/4. Okay, and then you should have y equals to 1/4 x plus 15 over 4. Okay, this is equivalent to minus x plus 4y equals to 15. Okay, this is our equation of normal. Okay, now for part C. Okay, for part C, okay, they tell you that the tangent to the curve at the point P. So what is the point P? The point, our point P here is what? 1 and 4 lah. Okay, the point that they give you in part A. Okay, so the tangent to the curve at 1 and 4 intersect the x-axis at S and the y-axis at T. So which means you have to find out the x and y coordinate of S as well as T. Okay, that is what they ask you to find, correct? Find the coordinate S and T. Okay, and since we know that, okay, the tangent to the curve at the point intersect the horizontal axis at S, right? This implies that the y coordinate of S is 0. Okay? Understand? Clear or not? Okay, the tangent to the curve, correct, at point P intersect x-axis at S. If you just look at the first statement, okay, the tangent to the curve C at the point P intersect the x-axis at S. So which means you take y equals to 0, you sub into the equation of tangent, not the equation of curve. Okay, so if you do that, okay, you plug in y equals to 0, okay, into the equation of tangent. Okay, you will get x equals to 2, because if y equals to 0, then you have 4x equals to 8, and hence x must be 8 divided 4, which is 2. So what is the coordinate of S? 2, 0 lah. So coordinates, okay, I short form, coordinate of S is 2, 0. Understand, Charlene? Now the next one, okay, the tangent to the curve at point P intersect the vertical axis at T. Okay, so just now is S, now intersect the vertical axis at T. This means x coordinate is 0. So you plug in x equals to 0 into the equation of tangent. Clear or not? Okay, plug in x equals 0 into the equation of tangent. Okay, this will use y equals to what? When x equals to 0, y equals to 8 lah. Okay? Understand? Clear or not? Therefore, our coordinate of t is 0, 8. Done. 明白吗? Okay, finish. Part C. Clear or not? Okay, so this is what you mean by the question. Okay, you plug in the x and y coordinate, which is 0, into the equation of tangent, not the equation of normal, neither the equation of curve. Okay, furthermore, you see your equation of curve, your x is sitting in the denominator. So how can you sub x equals to 0 in the denominator, correct? So you should actually plug into the equation of tangent. Okay, now for part D, the normal to the C are the same thing. Okay, it's actually the same. If you understand part C, then it's the same. Now instead of subbing the x and y coordinate, okay, you sub into equation of normal. Instead of subbing to the equation of tangent, you plug to equation of tangent, normal. Okay, so the normal to the curve at P intersect the line y equals to x at Q. Okay, and the line y equals to minus x at R. Find these two coordinate Q and R. So we do step by step. We find Q first. So the normal to the curve at the point P intersect the line y equals to x at Q. This means what? So you see, your equation of normal, from part B, you have what? Minus x plus 4y equals to 15. Correct or not? Okay, so what do you mean by the normal to the curve at P intersect the line y equal to x? Huh? What is your understanding?
Equate
Equate what?
the normal and the line.
Yeah. Okay, correct. Equate. Okay, so if you equate, okay, then what is your coordinate of Q? Huh? What is your coordinate of Q? Y equals to x is a what? It's just a straight line, right? That cut through the origin. Correct? That's your y equals to x. Correct? Y equals to x is just a straight line that cut through the origin. Okay, so you equate, what do you get? Okay, let me write here. This is for part D. Okay, part D. Any idea?
Hold up.
Okay, you see, our equation of normal from part B is what? Minus x plus 4y equals to 15, right? Correct? So, to find the coordinate of Q, okay, they tell you that, right, the normal to the curve at P intersect the line y equals to x, right? Which means you take y equals to x, you plug into your equation of normal, which means you replace the y with x. Understand? Okay, to find the coordinate of Q. Okay, so, okay, maybe let me copy the equation of normal down first. So this is our equation of normal. Minus x times 4y equals to 15. Okay, so plugging y equals to x into the equation of normal. Okay, this is what you get. So your y you replace with x. Okay, then you have what? Minus x plus 4x is what? 3x, right? 3x equals to 15. So what is x? 5 lah. Correct? Done. So if x equals to 5, what is your y coordinate? Same also, right? Because they tell you, right, the normal to the curve at P intersect the line y equals to x at Q. Correct? So if your x is 5, y is also 5. Correct? Because sama same. Okay? Okay. Okay, so coordinate of Q is 5, 5. 5, 5. Done. That's your Q. Okay? For the last one, okay, the normal to the curve at the point P intersect line y equals to minus x at r. So now it's no longer y equals to x, it's minus x at r. So the same thing lah. Okay, instead of x, you plug in y equals to negative x. Okay, so let me copy this first part. Okay. Okay, so you plug this now. Okay, just replace the x by minus x. Let me copy this part now. So this will be y will be replaced with minus x. Okay. Okay, then minus x minus 4x is what? Minus 5x, right? Equals to 15. Therefore, x will be negative 3. You follow me? Okay, and finally, what is your coordinate of r? Minus 3 and 3 lah. Okay? Clear? Minus 3 and 3 because why? Y equals to minus x. So if your minus x, okay, your x coordinate is negative 3, right? Okay, then your y will be 3. Okay? So that's the coordinate of r minus 3, 3. Clear or not? Okay, the last one. Show that QSRT is a square. Correct? So in order for QSRT to be a square, this tells you what? The sides must be congruent, right? Okay, because that is the property of square. So let me write here, part E. Okay, so how come change to euro? Okay, so okay, to show QSRT is a square. Okay, we require what? We require the sides to be congruent. Correct? Congruent meaning QS equals to SR equals to RT, okay, equals to QT. So QS equals to SR equals to RT equals to QT. Okay, because that is your property of square. All sides must be congruent. Okay, you think E-math will also cover this? Okay, so what will be the which means we need to find out the length, correct? The length of the sides QS, SR, RT, and QT, and because they are all the same, right? Correct? So how to find out the length of the side? Distance formula. Okay, from your coordinate geometry. Okay, so okay, let me just add on. Okay, we require QS to be equal to SR, RT, QT by property. Okay, is it property? Property of square and congruency. Okay. Then the next step, you need to find out the length. Okay, so the length. So we already know that the coordinate of S, T, Q, and R. Clear or not? Clear? Okay, so if you find the distance between Q and S, okay, it must be the same as S and R, as well as R and T, as well as Q and T. Okay, so we already have the coordinate, correct? S is 2, 0, T is 0, 8, Q is 5, 5, R is negative 3, 3. So the distance between QS is the same as SR, is the same as RT, is the same as QT. So we need to use our distance formula. Okay, so let me just bring out the square root. Okay, so I'm going to use some mathematical notation here. Okay, I think you may have seen it in vectors. I'm not sure whether you learned vector in E-math. So 2 vertical bar, okay, and then QS. This means 2 vertical bar equals, this means the length of QS. Okay, maybe I put here in words. Okay, distance and length is the same thing. Okay, distance or length of QS. Okay, the notation will be 2 vertical bar followed by QS. Okay, or in vector, okay, there's a term which called magnitude. Okay, the magnitude of QS. Okay, I'm not sure whether you have learned vectors okay, but okay, there's Sec 4, there's a chapter called vector in E-math. Okay, so the notation is this. Okay, so then you okay, and then what's the distance formula? X1 minus x2 square plus y1 minus y2 square, right? Which means the x coordinate of q and s, okay, in this case q is 5, correct? S is 2, so 5 minus 2. Okay, x1 minus x2 square plus y1 minus y2 square, right? That is your definition of distance formula, right? So the y coordinate of q is 5, the y coordinate of s is 0, so 5 minus 0. Okay, you square it, understand? Then you compute lah. 5 minus 2 is, okay, let me just do one more step just to show you. Okay, 5 minus 2 is 3, right? So 3 square plus 5 minus 0 is 5. So 3 square plus 5 square. And then what is 3 square? 9. 5 square is 35. So 25 plus 9, 34. Okay, and then your answer will be root 34. Okay, because this is an irrational number. Square root 34 is an irrational number. Okay, done. Finish. 搞了. Okay, if not, okay, if you want, okay, you can also try to find out the distance of SR, RT, and QT. Okay, they should be the same. Okay, because by property of square and congruency, okay, all sides must be equal. So maybe I just write an extra step here. Okay, this is also equals to the magnitude of SR as well as RT as well as QT. Okay, you can go and compute SR, the distance of SR, RT, and QT. Okay, you should have the same answer, which is square root 34. Okay, and then how the last thing is how do you prove that QSRT is a square? Okay, so this is how you prove the concluding remark. You can say that the normal is perpendicular to tangent at P. Hence, QSRT is a square. Okay. Okay, maybe later I show you on the graphing software. Okay, how to show that QSRT is square. You write down this statement first. Okay, normal is perpendicular to tangent at the point P. Hence, QSRT is a square. You know, then I'll show you on graphing software.
Sorry, can you repeat how the normal is perpendicular to the tangent at B?
This last line, is it?
Yeah.
Okay, I'm going to show you on graphing software so that you understand. Okay, what do you mean by, okay, it's 90 degree to the tangent at the point P. Okay, hence we conclude that QSRT is a square. So, okay, from part C, part D, correct? From part C and part D, right, you have your coordinate of S and T, right? Correct? So if I plot out the coordinate of S, T, Q, R, okay, let me do it here. So the first one is what? S 2, 0. Okay, and then T is 0, 8. And then Q is 5, 5. And then R is minus 3, 3. Okay, so if I plot out, okay. Okay, can you see that you get some kind of rhombus? Okay, if I join these 4 dots together, can you see? I get some kind of rhombus, right? Okay, or square. Okay, a 4-sided figure, quadrilateral, basically a four-sided figure. Okay, and then where is my point P? Our point P is 1, 4, right? And you will see 1, 4 is actually exactly in the middle of the square. So let me just show another coordinate. Can you see? Okay, maybe let me snip out this one. Okay, let me snip out. Where's my stepping tool? So lag. Yeah, I think because maybe I'm running the recorder software at the same time. Okay, that's why it's very lag. Okay, let me just copy out this one. Okay. Wow, sibei lag. Aiya. Okay, copy to my Word document. So, to answer your question, okay, let me open a new page. Okay, so now if I connect the 4 point, okay, the coordinate of QSRT together, okay, I will get a four-sided figure. So let me just quickly join them together. Hey, 需要开多新的 line， 麻烦。哎呀 cannot continue. Okay, from here to here, right? Okay, done. Okay, so I connected already. Okay, so once you connect the 4 points, the 4 coordinate together, QSRT, okay, you see that it's a four-sided figure quadrature. And then you see that your point 1, 4 is in the middle, right? Correct? And this point, no matter what, is always what? Tangent to the 4 points, correct? The 4 corner of the square. Correct? Not only is tangent to the 4 corner, okay, it's also perpendicular. Correct? Can you see? Okay, maybe let me draw another line out. Okay, and then I will put a dotted line there. Okay, so maybe let me just put this dotted line. Okay, can you see? Your 1, 4, okay, is always 90 degree at a point P. Correct or not? The same for the other direction. Okay, the same for the other direction. Okay, if I were to draw it. Okay, and then I just put some dotted line there. You can see. Okay, let me change the color a bit. Okay, let's say red color. Can you see the one in red color? No matter what is okay, your 1, 4, your point is always orthogonal or perpendicular to the square. Correct? Okay, so that is why I have this statement here. The normal is always perpendicular to the tangent at P. So here my P, maybe I put here 1, 4. Okay, then maybe it will be clear to you. Okay, so okay, the 90 degree is always there. Okay, and it's always tangent at the point 1, 4. Clear? Hence, we can conclude that this 4 point is a square, QSRT. Understand? Okay, just like in circles, there is this property, the radius is perpendicular to the tangent. But whatever is for circle, this is for square. Okay, so the same thing. Okay, you draw one line, okay, which cut through the point P. Okay, and you will see that is always 90 degree. Okay, and tangent at the point 1, 4. Can you see? Okay, so from this plot, this is how you come out this statement. Okay, okay, this is how I come out my statement. Okay, so maybe you can just draw the plot at the side. Okay, to help you understand what do you mean by this concluding statement. Okay, because they ask you to prove that QSRT is a square. Okay, so to prove that QSRT is a square, we need to prove that okay, the normal is always perpendicular, okay, and tangent to the point 1, 4. Okay, can I move on? Okay, so the last one, question 9. Okay, this one should be easy lah. Okay, only one part only. Find the equation of the normal to the curve at the point where x equals to 4. So here, some keywords to take note. Equation of normal. Okay? So step 1, you should know what to do lah. Huh? Differentiate lah. Find the gradient function. Okay, or the derivative function. Then, they tell you, right, what is the x value they give? 4. So after you differentiate, you evaluate the gradient at the point x equals to 4. Basically, sub in the x value equals to 4. Sub into your dy dx. Okay? Then, since I want to find equation of normal, right, I need to have my gradient of normal. So, minus 1 divided by dy dx, or your m value. Okay? Then, the last step, which is the fourth step, derive the equation of normal. Okay? So, I give you 5 minutes to, okay, you try first. Okay? I go toilet first. Huh? Okay, let me pause the recording first. Okay, so now, problem 9, okay, will be ask you to find the equation of normal to the curve, okay, where x equals to minus 4. So for this question, okay, like what Charlene brought out a question, okay, whether to use quotient rule or not. So at one glance, okay, you see that 2x minus 4 over x minus 3 is a rational function. Okay, so you may be quick to use quotient rule. That is not wrong. Okay, however, if you want to use product rule, then advisable for you to change it to this form. Okay, instead of leaving the original expression. Okay, so advisable to use this one. Okay, the one that I selected. Okay, if you want to use product rule. Okay, you should get the same answer. So I just quickly illustrate. So you use quotient rule. Okay, the final answer. Okay, use minus 2 over x minus 3 squared. Okay, similarly, if I use product rule, okay, my first term is what? 2x minus 4. I differentiate that, I will get 2. Correct? Then I keep the second term is x minus 3 to the power of minus 1. Okay, then plus 2x minus 4. Okay, here is where you have to be careful. Okay, so the second term is what? The power is minus 1. So when I bring down is minus 1. Okay, then inside no change. Okay, the power reduced by 1. So it's minus 1, minus 1, minus 2. Then differentiate the inside. Inside is actually x minus 3. Okay, so I differentiate that, I get 1. Okay. Okay, then you need to simplify a bit lah. Okay, so the first part you have what? 2 times x minus 3 to minus 1, right, is similar to 2 divided by x minus 3. Okay, and then this negative 1, okay, I can move to the front. So instead of plus here, it becomes minus. Okay. Okay, then 2x minus 4 will be in your numerator, and x minus 3 squared. Okay, so this is how you simplify lah. Okay. Okay, so then you realize that this part is not the same as this part, right? Okay, you see when I use quotient rule, okay, I get a single fraction. Okay, so actually you just need to do just a minor simplification. Okay, like EMAF, they give you this kind of fraction. Okay. Okay, you're on mute. Okay, can I continue?
Yeah, sorry, I can.
Okay, can. Okay, so you realize that once if you use product rule, you get down to this format. After you use product rule, you do some simplification. This does not tell you on top, right? Actually, you just need to simplify one more step. Okay, just like EMAF, correct? This can be an EMAF question, correct? The setter can give you 2 over x minus 3 minus 2x minus 4 over x minus 3 squared. Ask you to express this as a single fraction. So all you need to do is, okay, you just multiply x minus 3 to the top and bottom, okay, to the first fraction. Okay, so you have, okay, a common denominator of x minus 3 square. Okay, and then this will be 2 times x minus 3 minus bracket, okay, 2x minus 4. Okay, then you just simplify the numerator lah. Then you'll see that, okay, can you see this part here is the same as this part? Can you see, Charlene? The last step of my product rule is the same as the first step of my quotient rule. Can you see? 2 times x minus 3 minus 2x minus 4 divided by x minus 3 squared. Okay? Then you simplify. Okay, let me copy and paste the last line. Okay, so you simply, of course you expand first lah. Okay, the 2 and x you expand 2x. Okay, then it will cancel out with this minus 2x here. So kosong, 0. Then 2 times minus 3 minus 6 plus 4, negative 2. Okay, and then your denominator will be x minus 3 squared. Okay, you see, both I get the same answer. Okay, it's just preferences lah. Okay, which one you prefer. Okay, so if you don't like to work with rational function, you can move the denominator up. Okay, but when you differentiate the second term, specifically this part, okay, you need to be careful. Okay, of course, when you keep the first term, okay, the minus 1 when you bring down is actually here. Okay, clear? Then you subtract the power by 1. Okay, then this part, how you simplify is actually like that. Okay, this minus 1 I can move to the front. So instead of plus, it becomes minus. Okay, then 2x minus 4 will be in the top. X minus 3 to the power minus 2 will be in the bottom. Okay, then you simplify, you get down to the last step. So we see both are the same. You give the same result. It's just preferences, which one you prefer. Okay, now the next one will be, okay, you evaluate the dy dx, okay, at x equals to 4, right? Is it 4? Yeah, 4. Okay, so at x equals to 4, okay, let me copy and paste. At x equals to 4, okay, basically just sub in the value of 4 into your dy dx. So 4 minus 3, 1. 1 square is 1, right? So minus 2 divided 1 is negative 2. So our dy dx will be negative 2. Okay, let me check. Is the answer correct? Yeah. Okay, and I want to show equation of normal, right? Which means I need to find my gradient of normal. Okay, so my gradient of normal will be what? Minus 1 divided by m. Okay, where m is your dy dx. Okay, okay, so our gradient of normal will be negative 1 divided by m. Okay, where m is your value of dy dx. Evaluate at x equals to 4. Okay, okay, and then you have what? Minus 1 divided minus 2, half lah. Okay, the negative sign will cancel. Understand? Okay, then the last step, okay, you need to use the point, right? X1, Y1. So here, our X1, Y1 will be what? Here, your X1 is 4. But did they give you the Y1? No. So you need to find your Y1. Simply just sub in the X value equals to 4 into the original equation. This one, Y equals to 2x minus 4, not dy dx. Okay, so plugging x equals to 4 into, okay, let me copy paste this. Okay, I'm a very lazy person. Copy paste. Okay, plugging x equals to 4 into the original expression. Okay, not dy dx. Okay, this will give you your y1. Okay, because you need this point to derive your equation of normal. Okay, so you sub in x equals to 4. So the numerator is what? 2 times 4, 8. 8 minus 4, 4. Okay, then your bottom is what? 4 minus 3 is 1. So 4 divided by 1, 4. So when x is 4, y is 4. Understand? Then the last step, using the point 1, 4, equation of normal is what? Is what? Is y minus y1. Here our y1 is 4. Okay, maybe let me just put down here y1 and x1. Okay, just not to confuse you. Okay, so y minus 4 equals to, okay, our gradient of normal is half. Okay, times x minus x1. Okay, okay, let me just add on something here in front. So the two of you will understand. X1, y1. Okay. So in general, whenever you find the equation of normal or equation of tangent, you always need this point, x1, y1. Okay?
Wait, why is it x minus 1 and not x minus 4?
Hey, sorry. 4. Yeah. Thank you. Okay, so this is 4. That's why I put 1, 4, right? Yeah. Okay, yeah, x minus 4. Correct, you are right. Okay, where's my arrow? Let me copy on top. Okay, then you just do a bit of simplification. Okay, then you get y equals to, okay, half x, half times minus 4 is minus 2, minus 2, the negative 4 on the left you bring over, plus 4. Correct? So minus 2 plus 4 is 2. positive 2. Okay, so either you can leave it as this like that, or you can leave it as ax plus by equals to c, where a, b, c are real number. Okay, so okay, if you times 2 on both sides, then okay, and then we have minus x plus 2y is equals to 4. Okay, let me check. Minus x, okay, x plus 2y, x plus, okay, yeah, correct. Okay, so yeah, okay, so either you leave as y equals to mx plus c form, or you leave as general form. Okay, ax plus by equals to c. Okay, both are correct. Okay, and that's the answer. Okay, so okay, before we conclude today's stuff, okay, let me just illustrate this using graphical approach, so you understand better. Okay, instead of just blindly work out the working, okay, then you don't know what you are doing. Okay, so like I mentioned, double arrow means equivalence. Okay, so this or this is fine. The one that I bold, can see, if you leave as half x plus 2 equals to y, or minus x plus 2 equals to 4, both are the same thing, equivalent. Okay, so let me just quickly demonstrate this using graphs. Okay, since I'm using laptop here. Okay, so let me just erase everything. Okay, so what's the equation? Y equals to 2x minus 4 over x minus 3. Okay, this is your function, right? Okay, are you looking? Okay, then your equation of normal is half x plus 2 equals to y. Okay, maybe I show you here. Okay, half x plus 2. Okay, this is equivalent to minus x plus 2y equals to 4. Can you see? The black one and the red one, the color is the same. Can see or not? So both are equivalent. Okay, both are equivalent. So I'll just delete this. Okay, so you see, so what is the motivation of doing so much steps here? Okay, the motivation is, okay, the purple color is your original equation. Okay, the graph. Okay, 2x minus 4 over x minus 3. Okay, then after you differentiate, you find the gradient function. You submit x equals to 4. Okay, to find what the value of the gradient. Okay, and then find the gradient of normal. Okay, then after finally express the equation of normal, then you get down to minus x plus 2y equal to 4, or half x plus 2 equal to y. Okay, so what is the motivation? The motivation is basically, the motivation is trying to tell you here that, okay, here your equation of normal will bisect the hyperbola at 2 points. Okay, 1 point is here. Can you see? 4, 4. This point is what we found just now, correct? Where you sub in x equals to 4 into the original expression, correct? Can you see? This is down here, 4, 4. Okay, the other one is actually here, minus 1, 1.5. Okay, I never select only. Okay, so this is the other point. Okay, so the motivation is to tell you that the equation of normal is always normal to the curve. Okay, 90 degree lah. Okay, you can see that there is some sort of 90 degree. Okay, when the equation of normal, the black color one, cut the hyperbola. Okay, then you can see there's some sort of 90 degree. Okay, that's why it's called normal to the curve. Normal means perpendicular. Clear? Okay, so in case what is hyperbola, I'll just quickly show you. Okay, hyperbola is different from parabola. Parabola is a U-shaped or N-shaped curve. Hyperbola is two curves that never face each other. Okay? Okay, you get something like that. Can you see this one? Okay, two curves that are facing away each other, they will never meet each other. Okay, they will never touch each other. This is hyperbola. Clear? Okay, so this is to illustrate to you that the equation of normal is normal to the hyperbola, 2x minus 4 over x minus 3 at these 2 points, 4, 4 and negative 1, 3 over 2. Okay, 3 over 2 is 1.5. Clear? And 4, 4 is clearly one of the points that we see just now. Clear or not? Okay, so today we see 3 questions. Okay, question 7, question 8, question 9. Okay, and I think one of the question 7, okay, part B, okay, actually make use of what you learn in polynomial, how you solve cubic equation. Okay, and here I use one of the classical approach is trial and error. Okay, of course you can use factorization if you know how to do it. Okay, so before I conclude today's session, okay, I just want to quickly run through with you the notes, okay, so that next week, okay, we can straight away start on the question. Okay, I don't need to repeat again what is stationary point, what is first derivative test, second derivative test. Okay, so okay, next week you come, you can just straight away do, okay, the question. Okay, I can save time to explain. Okay, so first thing, increasing and decreasing function. So this means, okay, what? The gradient of increasing function are always positive, which means dy dx. Recall, gradient function is your dy dx. Okay, that's why they put here f prime x is positive. Okay, the gradient of decreasing function are always negative. Okay, which means dy dx is always negative. Okay, then the next point is important. Okay, this one is very important. Stationary point. Okay, so stationary point, okay, actually typically, okay, we have two different, in calculus, there is two approach. You can use the first derivative test or the second derivative test. So we talk about first derivative test first. So for first derivative test, as the name infer, first derivative test, which means you differentiate one time. So your original function, let's say if it's f of x, okay, you differentiate one time, okay, then to find the stationary point, you set the derivative function to 0, i.e. f prime x equal to 0. Okay, then you find the roots of x or solution of x. Clear? Then if, okay, let's say if your stationary point is x equals to 2, okay, then on the left side of 2, okay, which means it's the negative value, right? Okay, if x is equals to 2, okay, on the left side of 2, if it's negative, and on the right side of 2, if it's positive, then we have a minimum point. Okay, you can see the bullet point, if f prime x changes from negative to positive, okay, as it passes through the stationary point. Okay, so okay, let me illustrate. Okay, I will use this software to illustrate. Paint, got paint or not? Okay, have. Okay, let me just draw here to explain. 鸡蛋糕要 install 他妈的。Okay, wait, any other drawing tool I can use? Okay. Okay, how to explain this? How to explain this? Okay, anyway, if it's negative positive, then it's the minimum point. If it's positive negative, maxima point. Okay, if it's negative negative or positive positive, then point of infraction. Okay, that's basically first derivative test. Okay, later I think I'll quickly use the example to explain. Okay, for a second derivative test, as the name infer, second derivative test, which means after you find the first derivative, you differentiate one more time. Okay, you differentiate one more time. Okay. Okay, you need to go off, is it? Do you need to go off? Okay, you're mute. No need.
No need.
Okay. So, okay, anyway, I'm just going through in advance first. So next week, okay, we can just jump straight into the question. Okay, so for second derivative test, okay, as the name implies, second derivative, so you differentiate one more time. After you differentiate, find the first derivative, you differentiate one more time, and the notation is, you can see here, f double prime. Okay, first derivative is f prime. For second derivative is f double prime, or basically y prime prime. Okay, or d2y over dx squared. That is the second derivative. Okay, then you can see that the second point and the first point of first derivative is the same. Okay, to find the stationary point, you set the first derivative to 0. So what's the purpose? To find the solution of x. Okay, it's like finding it's like I give you a quadratic equation and then you solve for the roots of x. The same thing. Okay, so that is finding stationary point. Okay, then the next step, you evaluate, okay, the stationary point. Basically, you sub in. If let's say step 2, if your stationary point is x equals to 2 and x equals to minus 2, then you sub into your second derivative function. You sub x equals to 2 and x equals to minus 2 in your original function. Okay, if after you sub in, let's say x equals to 2 into the second derivative function, if let's say if it's positive, which means x equals to 2 is a minimum point. Okay, minima is singular. Okay, minimum is poor. Okay, so you submit x equals to 2 into your second derivative. If it's positive, then x equals to 2 is a minimum point. Okay, then x equals to minus 2, you sub into your second derivative. If it's negative, which means x equals to minus 2 is the maximum point. Okay, if it's equal to 0 means no conclusion. Okay, that's why you see inconclusive. Okay, or the test fail. Okay, I quickly use one example to go through, then we call off the session. Okay, just let me quickly, okay, I use example 5. Okay, I use example 5. So you, okay, either you look at the screen or you look at your handout example 5. Okay, just to quickly explain how to use first or second derivative test. Okay, so for example 5, okay, they ask you to find the stationary point. So the keyword is stationary point. Okay, and then state their nature. So nature means, is it a maximum point or minimum point where the stationary point is? That is basically nature. Okay, so as usual, okay, f of x here is a polynomial function in x of degree 3. So the first step, you differentiate this f prime x. Okay, then you get 3x squared minus 6x minus 24. Okay, then to find your stationary point, you set your f prime x to 0. Okay, clear or not? And this is like a quadratic equation, like 3x squared minus 6x minus 24 equal to 0. It's like doing E-math problem. Okay, how you solve quadratic equation. Okay, then you get down to x minus 4 and x plus 2. Therefore, the stationary point or the roots is 4 and minus 2. Okay? Clear? Okay, now let me quickly demonstrate. Okay, wait, is there any pen I can use here? Okay, if not, I will explain. Okay, I'll use the whiteboard to explain next week. Okay, so right now our stationary point is 4 and minus 2, right? So if maybe I use this page to explain. Okay, let me draw a line first. Okay, so I can draw sui lah. Okay, so this is 4. Okay, what's the other one? Minus 2, right? Okay, right? This is your stationary point, right? Right or not? So how to use first derivative test? Very simple. Okay, you evaluate the left side of your stationary point. So after minus 2 is what? Minus 3, minus 4, right? Correct or not? You have minus 3, minus 4, so on and so forth, right? Correct or not? So if let's say you submit minus 3, okay, into your original function. So if you submit minus 3 into f of x, what is the answer? Can you quickly submit? You plug in minus 3 into the original function. Minus 3 cubed, minus 3 times minus 3 square, minus 24 times minus 3, minus 28. What is the answer? Is it a positive or negative?
I got negative 10.
Negative answer. Okay, so you see, basically, okay, you take any value up beside, you see, the example they use minus 2, right? Correct or not? Obviously you get 0, correct? But I don't want to directly ask you to submit the stationary point, the value minus 2 into the original function. That's why I asked you to submit minus 3. In fact, you take any other value after minus 2, minus 3, minus 4, minus 5, etc. Okay, you sub into f of x, you get a negative answer, right? Correct or not? Which means at x equals to minus 2, this is negative. Understand? Can you see? Okay, at x equals to minus 2, this is negative, right? Okay, now, okay, the next stationary point, x equals to 4, correct? If you take any other value, okay, or you take 4, you sub into f of x, what do you get? You get minus 108. Okay, or rather you take 5. Okay, let's say you take 5. Okay, you take 5. Okay, can you sub in? If you take x equals to 5, you sub into f of x. 5 cubed minus 3 times 5 square minus 24 times 5 minus 28. Okay, you should get a positive answer.
Positive?
Do you get positive?
No.
What you get? Negative.
Yeah. Wait. 5, right?
Yes. Plug into the f of x, the original function.
Minus 3x. Yeah, I got negative.
Wait, sorry. Wait. I think you should sub into the f prime x. Yeah, sorry. Okay. Okay, yeah, okay, sorry, my mistake. Okay, you should sub into the f prime x instead. Okay, can you try again? For x equals to minus 3, can you sub into f prime x instead? Sorry, my mistake. Okay, can you sub into f prime x?
Minus
3.
for minus 3?
Yes,
3 or minus 3?
minus 3. Okay, because you see, your stationary
Okay.
point is what? Negative 2 and 4, right? Correct? On the left of minus 2 is what? Minus 3, minus 4, right? Correct? Then in between here is what? In between minus 2 to 4 is what? Minus 1, 0, 1, 2, 3. Correct? This is in between your stationary point, right? Correct? So if you take minus 3, minus 3 onwards, correct? And then you plug into your f prime x. Okay, what is the value?
I got 21.
Positive, right? Correct?
Yeah,
Positive,
positive.
which means increasing. Correct? So at x equals to minus 2 is actually increasing, right? Can you see the arrow? Okay, just now it's actually wrong. Salah, wrong. Just now it's decreasing. Now arrow. Okay, now if you take from 4 onwards, let's say 5, 6, 7, 8. Okay, let's say you take 5. You plug into your derivative function f prime x. Do you get a positive or negative? You should get a negative. Okay, can you try? You plug 5 inside your f prime x.
Also 21 eh.
Positive.
Yeah.
Okay, wait. Okay, wait. Minus 3 is positive. Okay, okay, can you try 3 instead? Can you sub in 3? 3 is some between your stationary point, right? Between minus 2 and 4. Okay, you plug in 3 first.
Negative.
Negative. Okay, so you see, so here is negative. Correct or not? So at x equals to 2, so what your first derivative test is trying to tell you, at the stationary point, x equals to minus 2. Okay, you know this minus 2, 4 come from where, right? Come from here. This one. After you differentiate, you set it to 0. Okay, then you get the roots. Correct? 4 and minus 2. This, I'm talking about this. This is your stationary point. Okay? This is where your minus 2 and 4 come. Not drop from the sky. Come from this step here. Okay? So your 4 and minus 2 is actually, okay, after you differentiate, you set to 0. Okay, basically you factorize the equation, solve for the roots. Okay, then this is your stationary point. Okay, so what first derivative test is telling you is basically at each of the stationary point, what is the change? If it's positive to negative, then maximum point. Okay, positive to negative, then maximum point. Okay, you can see the notes. This one, 1, 2, 3, the third bullet point. Can you see? Positive to negative, maximum point. Negative to positive, minimum point. Or minima point, same. Okay, so that is what the notes is telling you. Okay, so at x equals to 2, okay, that's why I asked you to sub in 2 number. Correct or not? The first number I gave you is what? Minus 3, right? Right? What's the second number? 3, is it? Okay, so that's why I give you these 2 number, correct? To the left of minus 2 and to the right of minus 2. So to the left of minus 2 is negative 3. So when you sub in minus 3, what do you get? A positive value. This means increasing. Understand? To the right of minus 2 is 3. Right? You sum in 3, what do you get? Negative value, right?
Negative.
Correct? Yeah, lor. So you can, so what can you conclude? You can conclude that x equals to minus 2, okay, is a maximum point. You can see the notes here. X equals to minus 2. The last one, can you see? Therefore, minus 2, 0 is the maximum point. Actually, you don't need the 0. Okay, you can just say that x equals to minus 2 is the maximum point. Okay, you just need to show, okay, the first two parts. So the first two part will be, in your case is, I ask you to submit minus 3 and 3, right? So minus 3, you get positive, right? Then 3, you get negative, right? Correct? So in the example, you can just replace, instead of f prime minus 1, you can just replace with f prime 3. Okay, you know what I'm saying or not? Instead of f prime minus 1, okay, you just replace with f prime 3. Okay, then you sub in, you get a negative answer. Okay, and this tells you that x equals to minus 2 is a maximum point. This is for this part here. Clear? Okay, let me change color. Green color. So now for x equals to 4, to the left of 4, let's say you pick, let's say example you pick 3. Okay, we know that it's negative, right? Correct? Correct or not? To the left of 4 is what? 3, 2, 1, 0, etc. Correct or not? Based on your number line. Correct? Number line, right? 0, 0 is here, right? Correct? To the right of 0, 0 is all positive number until infinity, right? You have 1, 2, 3, correct? To the left of 0, you have minus 1, minus 2, minus 3, correct or not? Correct? So at your stationary point, x equals to 4. Okay? If you evaluate to the left of 4, which means 3. Example, you take 3. Okay, we know that it's negative, correct? Because just now you sub in x equals to 3 into your f prime x. What do you get? A negative value. This means it's what? Decreasing, correct? Now, to the right of 4, let's say you take 5. Okay, can you sub in 5 into your f prime x? You should get a positive value. Yeah, lor. Understand? So, you see, for x equals to minus 2, it's going from positive to negative, and this is what? Maximum. Correct? Okay, it's going from positive to negative, so this is maximum. Okay, then for x equals to 4, it's going from decreasing to increasing, right? So, minimum. Can you see the line that I write here below? Correct? So, x equals to minus 2 is maximum. Okay, wait. X equals to minus 2.
We can take.
Sorry, can take what?
We can take any number, right?
Yes, based on your stationary point. Like for example, here our stationary point is minus 2 and 4. So if you take to the left of minus 2, basically you want to take minus 4 also can. So you don't like minus 3, you want to take minus 4 also can. It will be a positive number. You try lah, you submit minus 4 into your f prime x. You should get a positive number. Okay, then this means that is increasing. Okay, so to answer your question, yes, you can take any value. Okay, in fact, to the left of your stationary point, you can take any value you like. You want, you can take minus 2026, but they are too big lah, or minus 2025, but too big already. Okay, so you take, just now for minus 2, right? To the left of minus 2, I take minus 3. You want, you can take minus 4. Okay, you should get positive answer. This means, positive answer means increasing. Okay, negative value means decreasing. Understand? So, one positive, one negative, that is maximum. Clear? One negative, one positive, or one decreasing, one increasing, that means minimum. Clear? This is how you understand first derivative test. Okay? Clear or not? Understand? So you evaluate to the left and right side of the stationary point respectively. So for minus 2, you take any value that is on the left side of minus 2. Minus 3 onwards lah. Minus 3, minus 4. Then to the right of minus 2, you can take minus 1. In fact, if you don't like 3, you take minus 1. Okay? And then you sub into f prime x. It should be a negative value. Okay? Then negative value means what? Means decreasing lah. Just like the down arrow I draw here. Can you see? Clear or not? Okay? Then for x equals to 4, the second stationary point, you take to the left of 4, 3. Okay, but we already know that it's a negative answer. So, negative value means decreasing. Okay, then to the right of 4, okay, you take 5 or 6. Okay, you sub into f prime x. If you get positive value, means increasing. Okay, so one is negative to positive. The other one is positive to negative, which means we have two different points here, max and min. But you need to make sure which stationary point is at the maximum, which stationary point is at the minimum. Do not confuse between these two. Okay, if you say that x equals to minus 2 is the minimum, wrong. X equals to minus 2 is your max. Can you see here the line that I draw? Okay, let me erase again. See, this part here is the max. Can you see? Okay, increasing, right? decreasing, right? So this is your max. Then the other end, decreasing, increasing. So this is your minimum. So x equals to 4 is my minimum. X equals to minus 2 is my maximum. And this tally with what the notes written. X equals to minus 2 is maximum. X equals to 4 is minimum. Can you see? Clear? Okay, so maybe let me just quickly edit this. Okay. Okay, maybe just let me draw a text box. Where's the text box? Here. I want to write some notes. Okay, here. Okay, so for I start with minus 2 first, right? Okay, so okay, for minus 2, okay, you take to the left side of minus 2. So let's say I take minus 4, okay, or minus 3. Okay, so you go and sub into your f prime x. So let's say my f prime minus 4 or minus 3. Okay, this should be a positive value, right? Yeah, okay, so this means, okay, positive value means increasing. Okay, 叻呀！他妈的，快点嘞，2点半了，hang already。哎呀！ Okay, I think because I'm running 2 recorder at the same time. Okay, so this means positive means increasing. Okay. Okay, then what's the other value that I pick? To the left of minus 2, 3. Okay, or you want you take minus 1 also can. Okay, so I take 3. Okay, then you sub into your f prime x. Okay, you get negative value, right? So okay, means decreasing. Okay, so what is your conclusion? Increasing, then decreasing, right? So it's like a mountain shape, correct or not? Increasing, then decreasing. So maximum lah. So we can conclude that x equals to minus 2 is a maximum point. Okay? Okay, this is another way to show using your first derivative. No need like the notes. No need to state the y coordinate of minus 2. No need. Okay, as long as you show that the stationary point is going from increasing to decreasing, okay, then it suffice to say that x equals to minus 2 is maximum point. Okay, let me copy and paste this for the other one. Okay, so for x equals to 4, okay, if you take 3, okay, you evaluate to the left side of 4, which is 3, okay, and 3 we already know is a negative value. So f prime 3 is the negative, right? Why so long? 哎呀，他妈的，现在还出来Okay, so f prime 3 is negative. Okay, this means it's decreasing. Okay, and then okay, you evaluate to the right of 4. Let's say you take 5. Okay, and this is a positive answer, right? Correct? Yeah. Okay, positive answer means increasing. Okay, so x equals to 3 is decreasing, 5 is increasing. Okay, so decreasing, increasing, this means x equals to 4 is a minimum point. Okay, this is another alternative. Okay, no need to follow like what the example state. Okay, so okay, you evaluate to the left of 4. Let's say it's 3, because left of 4 is 3, correct? You sub into your f prime x, you get a negative value means decreasing. You get a positive value means increasing. Okay, then to the right of 4 means 5, 6, 7, 8, 9. You pick any value. Okay, after 4, that is to the right of 4. Then you sub into f prime x. If it's positive value means increasing, then what can you conclude? One decreasing, one increasing. So it's like a V shape, correct or not? Decreasing, increasing. Means minimum lah. Means x equals 4 is minimum. Correct? There. Done. Clear? So this is another alternative. Okay? Beside this one, beside what you see in the notes. Okay? You can just conclude like this way. Okay? Okay, then maybe you can write the last part here. By first derivative test. Okay? Okay, you can just add in this one. Okay, x equals to 4 is a minimum point. Okay, by first derivative test. Because we have two methods to find out whether the stationary point is min or max. Okay, minimum or maximum. Okay, there are two approaches. One is using first derivative. The other one is using second derivative test. Okay? Clear? For second derivative test, okay, it's quite straightforward. Okay, I use example 4 to illustrate. So the first thing, as usual, you differentiate, you set to 0. Okay, set to 0 means you solve the equation. Okay, you solve the f prime x, then you get two value, correct? X equals to 1 or minus 2. Okay, then for second derivative test, easy, you just differentiate one more time. So you differentiate one more time, you get 12x plus 6, right? Okay, then you sub in the stationary point directly into your second derivative function. So for x equals to 1, you sub in, you get a positive answer, right? Which means x equals to 1 is the minimum point. You can see that in words. Okay, x equals to 1 is minimum point. Okay, then you sub x equals to negative 2 into your f prime prime x, your second derivative function, you get a negative value. Correct? Which means x equals to minus 2 is a maximum point. Straightforward. Okay, second derivative is very simple. Okay, you differentiate 2 times. Okay, then you find the stationary point. Okay, by setting f prime x to 0. Then you sub in your stationary point into the second derivative function. Clear? If it's positive, means your stationary point is occurring at the minimum. If it's negative, if your second derivative is negative, means your stationary point is occurring at the max. Opposite lah. Okay, negative means minimum. Sorry, negative means maximum. Positive means minimum point. Okay, that's for second derivative test. Okay, then for first derivative test, okay, I illustrate here using my hand drawing down here. Understand? Okay, this is for first derivative test. Okay, then the last part, which is on this one, the gradient of increasing and decreasing function. This one I will illustrate next week. Okay, so for now I already explained. I know I overrun already. So for now I already explained the stationary point using the first derivative and second derivative test. Okay, so if you don't understand what it means by f prime x changes from positive to negative, okay, as you pass through the stationary point is maximum point. Okay, you look back at the recording, refer to this part. Okay, this is what I mean by using first derivative test. Okay, you evaluate to the left and right side of the stationary point respectively. Okay, then you sub in numbers. Then you see that what is the change when you sub in x equals to minus 3. Is okay. If it's increasing, then it should be a positive value. If it's decreasing, then it should be a negative value. Clear? Okay. Then same for the other stationary point. Okay, you evaluate to the left and right of the stationary point. Okay, basically the behavior lah. Okay, what is the behavior of the left and right side of the stationary point? Clear? Okay, so to answer your question, yes, you can pick any value. Okay, so for minus 2, okay, when you want to evaluate the behavior, okay, to the left of minus 2, you can take any value, minus 3, minus 4, minus 5, minus 6, etc. Okay, then you want to evaluate the behavior. Behavior means whether is it increasing or decreasing, positive or negative. Okay, you take any value to the right of minus 2. It can be minus 1, 0, 1, 2, 3, so on and so forth. Clear? Okay, so I stop here for today. Okay, if you want, you can go and try the exercise. Okay, you can go and try. Very simple one. Okay, so maybe, okay, you can start trying question 3, because question 3 asks you to find the stationary point and determine the nature. Okay, so you can go and try first. Okay, then next week we will go through. Okay, the first 2 questions is on the gradient of increasing function is positive, the gradient of decreasing function is negative. That's the first 2 questions. Okay, starting from question 3 is what I have just explained. Okay, about the first and second derivative test. Okay, so for the nature, you can use either one, first or second derivative test. Okay, you can use either test. Okay, but I suggest you to try with both approach. Okay, try with both approach. So at least, okay, you are familiar with the 2 tests. first and second derivative test. Okay, that is for the second part. Determine the nature means use your first and second derivative test. Find the stationary point means you differentiate, set to 0. Solve the equation. Solve for x, where your x here is a stationary point. Okay, then the nature, okay, if you use the first derivative test, then you need to evaluate the left and right side of the stationary point. Evaluate what is the behavior. Whether is it positive, negative, or negative, positive. If it's positive, negative, maximum. Negative, positive, minimum. Clear? Yeah. Okay, question 3. Clear? That's for exercise 2, very short. Only 3 questions. Okay, then after that, exercise 3. Okay, so go and try lah. Okay, I suggest you go and try question 3. Can? Anything you want to ask me? Okay, let me stop the recording first.